10.2 Product of Powers property. There are a few key ideas with the product of powers property. So let's begin first with the product of powers property. This is to multiply powers with the same bases. You add their exponents. So for example, if we have 4 to the second power times 4 to the third power, you have the same base of 4. Then you want to add the exponent of 2 plus 3. So that becomes 4 to the fifth power. Another way of showing this is algebraically with a to the m times a to the e, which is a to the m plus e. Next, we have power of a power property. For a power of a power property, to find the power of a power, you multiply the exponents. So for this one, if you have 4 to the sixth power raised to the third power, you make that 4 to the sixth times 3, which becomes 4 to the 18th power. So to show it algebraically, that's a to the m power raised to the e power. That becomes a to the me power. And the last one is power of a product property. This is where you find the power of each factor and multiply. So for example, if you had 3 times x to the fifth power, that would become 3 to the fifth power times x to the fifth power. Or showing it algebraically, if you have a b raised to the m power, that becomes a to the m times b to the m. So you are distributing that m to both terms inside of your parentheses. So let's try some examples. Multiplying powers with the same base. Well, if I go back up here, products with the same base, well, that's referring to the product of powers property. So I'm going to add that in here. Product of powers property. When you have the product of powers property, if I go back up, it says to multiply powers with the same bases, add their exponents. So if we have 2 to the 4th power times 2 to the 5th power, that becomes 2 to the 4 plus 5. So that's 2 to the 9th power. But let's actually show why that is 2 to the 9th power. So if I rewrite 2 to the 4th power times 2 to the 5th power, I want to start by writing 2 to the 4th expanded. 2 times 2 times 2 times 2. So I need 4 2's. Then I need 5 2's for 2 to the 5th power. There's 1, 2, 3, 4, 5. Now I'm going to count how many 2's I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this becomes 2 to the 9th power. Same answers. I just didn't have to do all the work of writing out all those factors. Letter B, -5 times the quantity -5 to the 6th. Well, I'm going to put this -5 in parentheses and put an imaginary 1. If you have the quantity -5, that's referring to one of those. So this becomes the quantity -5 to the 1 plus 6 power. So the quantity -5 to the 7th power will be my final answer. But again, to show it longhand, -5 to the 1st power times -5 to the 6th power. I need 1 -5, and then I need 6 -5's. So 1, 2, 3, 4, 5, 6. Now I'm going to add up all of my -5's. 1, 2, 3, 4, 5, 6, 7. So it becomes -5 to the 7th power. Again, same answer, just less work when we use the product of powers property of keeping the base the same and adding the exponents. All right, letter C. X to the 3rd power times x to the 7th power equals x to the 3rd plus 7, x to the 10th power. Once again, if you want to expand it out, you can. You need 3 x's for the first term and 7 x's for the second. So 1, 2, 3, 4, 5, 6, 7. And I'm going to add them all together, or count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So x to the 10th power. Again, same answer, just less work when you just add the exponents. Okay, next set of examples. Finding a power of a power. So we are doing power of a power. If I go back up, I can highlight product of powers. So as a reminder, when you have the power of a power, let's see what the definition says. To find the power of a power, multiply the exponents. Okay, so for letter D, that's 3 to the 4th times 3. 3 to the 4th times 3 is 3 to the 12th, because 4 times 3 is 12. My base stays the same of a 3, so 3 to the 12th power. However, let's show this work. 3 to the 4th power times 3 to the 4th power times 3 to the 4th power. The reason I wrote that 3 times is because it is indicating that I have a power of 3. Well, from here, I can write out 3 to the 4th power with 4 3's 3 times and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this becomes 3 to the 12th power. Again, same answer. That method just gives me more work. Also, eventually, we're going to have exponents that are going to be very large, and in order to show it, that would not be the best use of our time. All right, so letter E, we have w to the 5th power raised to the 4th power. Well, when you have one base and 2 exponents, you multiply those exponents. So w to the 5th times 4, w to the 20th power. But again, we can show our work. W to the 5th times w to the 5th. I need a total of 4 of those. Then from there, I could expand it out. There's one set of 5 w's, 2 sets, 3 sets, 4 sets. When I add them all together, it still gives me w to the 20th power. Example 3, finding a power of a product. Power of a product. Going back up to the definition. Power of product property states find the power of each factor and multiply. So 2x to the third power. This is where I'm going to distribute a 3 to the 2 and a 3 to the x. So that's 2 to the third power times x to the third power. Well, 2 to the third power is 8, so that leaves you with 8x to the third, or 8x cubed. Again, we could show the work differently by going the quantity 2x times the quantity 2x times the quantity 2x. And then using the commutative property of multiplication, put my like terms by each other. 2 times 2 is 4, times 2 is 8. And then you have 3 x's, so that's x to the third. Same answer, just written differently. Letter G, 3xy all to the second power. So this becomes 3 squared times x squared times y squared. 3 squared is 9, x squared is x squared, and then y squared. Once again, you could show this is 3xy times quantity 3xy. You can do combining your like terms, so 3 times x times y times y. That's 9x squared y squared. So let's try some problems on your own. You're going to simplify the expression and write your answers as a power. So the next few sets, or the next few problems, are a mixture of all 3 of the product of powers properties. Well, whether it's a product of power, the power of a power, or power of a product. So letter H, well, that is going to be the product of powers. I have the same base, so that means I'm going to add the exponents. 6 squared plus 4 equals 6 to the 6th power. If you prefer, you could write 6 times 6 times 6 times 6 times 6 times 6. So you have 2 6's times 4 6's, a total of 6 6's, so 6 to the 6th power. All right, letter I, same idea. You have the same base, so I'm going to keep the base of negative 1/2, and I'm going to add the exponents. 3 plus 6. It's quantity negative 1/2, all raised to the 9th power. Again, you can expand it out if you would prefer. Letter J. Well, this one might be a little hard to see, so I'm going to put an imaginary 1 with my first z. So that indicates that we have z to the first plus 12. Again, same base, we're multiplying, so we want to add the exponents. So that becomes z to the 13th power. Again, you can expand it out with z times, so 1z times 12z. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. When you add them all together, that gives you z to the 13th. All right, letter K, L, and M. All 3 of those are power of a power. So when you have one base and 2 exponents, that means you're going to multiply those exponents. So 4 to the 4th power times 3 becomes 4 to the 12th power. If you want, you can write 4 to the 4th times quantity 4 to the 4th times quantity 4 to the 4th. So I wrote that out 3 times, and I would write out 4 4s 3 separate times. When I add those all together, or when count all of them, that's 4 to the 12th power. Letter L, y to the 2nd power raised to the 4th. Again, we have one base, two exponents, we're going to multiply. Y to the second times 4, that becomes y to the 8th. Again, you can expand it out if you would like. Letter M, the quantity -4 to the third power raised to the second power. Same base. I'm sorry, there's only one base, so you multiply the exponents. -4, that quantity raised to the third times 2, is the quantity -4 to the sixth power. Again, you expand that out if you would like. All right, letter N, O, and P is simplifying the expression. That is a power of a product property. So that means that I want to distribute my exponents to every term that's on the inside of my parentheses. So I'll do 5 to the fourth power, y to the fourth power. So 5 to the fourth power, y to the fourth power. Well, the only thing left from here is to actually find 5 to the fourth power. I recommend using our calculator. So that's 625 y to the fourth power. All right, letter O. 2 to the fifth power times a to the fifth power times b to the fifth power. I'm just distributing this fifth power to all three terms. Well, 2 to the fifth power, when you plug that in to your calculator, is 32. A to the fifth is a to the fifth, and b to the fifth is b to the fifth. So 32, a to the fifth, b to the fifth. Letter P, 5/10 mn, all raised to the second power. Distributing the second power to all three terms. 5/10 squared times m squared times n squared. So 5/10 squared is going to be 25 hundredths. M squared is m squared, n squared is n squared. If you wanted, I'll show on letter P, you could have expanded it out as 5/10 mn times quantity 5/10 mn. Then you want to put your like terms together of 5/10 times 5/10 times m times m times n times n. Still going to give me 2500 m squared n squared, just a different way of showing that work. Bear with me a moment. Okay, example 4, simplifying an expression. Letter Q. A gigabyte, which is abbreviated GB, of computer storage space is 2 to the 30th power bytes. The details of a computer are shown. How many bytes of total storage space does the computer have? Well, it's saying total storage space, so it's referring to this, 64 gigabytes. So total space is 64 gigabytes. But it's asking for how many bytes. Well, that first sentence states a gigabyte of computer storage space is 2 to the 30th power bytes. So we want to find the total number of bytes with knowing that the number of bytes in a gigabyte is getting multiplied by the number of gigabytes. So let's start with the number of bytes in a gigabyte. Well, that's 2 to the 30th power. And we're multiplying by the number of gigabytes. Well, there are a total of 64 gigabytes. In order to combine our like terms, I'm actually going to convert 64 to a power of 2. So 2 times 2 is 4, times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. Well, this equals 64, which is 1, 2, 3, 4, 5, 6. 2 to the 6th power. So instead of writing 64, I'm going to write 2 to the 6th power. The purpose for that is we already have a base of 2 to the 30th power. Now we're multiplying by a term of 2 to the 6th power. It has the same base. So I'm going to rewrite the same base and I'm going to add these exponents. So if you have a total storage space of 64 gigabytes, that's actually going to be 2 to the 36th power bytes.